This video summarizes the Math 1 lesson titled Taking Sides. This is a practice understanding task. The purpose of this lesson is for students to solve inequalities and construct viable arguments to justify a solution and method. In this task, Joaquin and Serena are working together, and sometimes they have disagreements on how to solve the problems. Your job is to decide how to answer their questions and decide who is right and give a mathematical explanation of your reasoning. So Joaquin and Serena are assigned to graph the inequality x is greater than or equal to -7. Joaquin thinks the graph should have an open dot at -7, but Serena thinks the graph should have a closed dot at -7. Explain who is correct and why. Serena is correct this time. You should have a closed dot. The reason why is because the symbol is greater than or equal to. And if you're on a number line, if you have an open dot, it would be just greater than, not greater than or equal to. The open dot represents a space that is not filled in. It's not a part of the solution. So the open dot means that -7 is not a part of the solution. However, in this situation, x could equal -7. So we fill in the dot to show that there is this area here that is filled in at -7, meaning -7 is a part of the solution. So for number 2, Joaquin and Serena are looking at the problem 3x plus 1 is greater than 0. Serena says that the inequality is always true because multiplying a number by 3 and then adding 1 to it makes the number greater than 0. Is she right? Explain why or why not. No, unfortunately this time she is not right. For some values it does work. However, she's not considering all values. For example, if we substituted in a negative value, if we have 3 times -2, for example, plus 1, we have 3 times -2 gives us -6. -6 plus 1 gives us -5. And -5 is less than 0, not greater than 0. So this is not always true. If we wanted to find out a little bit more about which values it actually did work with, because she does have a point, it's just she said always true, and this is not an always true situation. So we could solve the inequality to figure out which values actually do work. So if I have 3x plus 1 is greater than 0, to solve, I'll start by subtracting 1 on both sides of the inequality. Remember, that's the subtraction property of inequality. Does not change the sign. And then I'll divide by 3. And since I'm dividing by a positive number, the sign will stay the same. And I have x has to be greater than -1/3. So if x is greater than 1/3, then it's a true statement. However, if x is less than or equal to -1/3, then it would not be true. For number 5, Joaquin's question in number 4 made Serena think about other similarities and differences in equations and inequalities. Serena wonders about the equation -x divided by 3 equals 4, and the inequality -x divided by 3 is greater than 4. Explain to Serena ways that solving these two problems are alike and ways that they are different. How are the solutions to the problems alike and different? So let's first start by solving the equation -x divided by 3 equals 4. I'm going to start by multiplying both sides of the equation by 3 to get -x equals 12. And then I'll divide both sides of the equation by -1 to get x equals -12. Then for the inequality, I follow the same steps by multiplying both sides of my equation by 3 and then dividing both sides of my equation by -1. And here my sign will change from greater than to less than, and I have -12. So the steps were very similar. In both, I started with multiplying by 3, and then I divided by -1. The difference is, however, with the inequality, because I was dividing by a negative, I had to make sure that I flipped my sign. The solutions are a bit different. If I think about that number line again, when I have -12, and I have x equals -12, then that is a solid dot right here at x equals -12. However, if I do the inequality, I have an open circle because the solution is not on the -12, the solutions are actually the values that are lower than negative 12. So the steps are the same, with the exception of remembering to flip the inequality sign for the inequalities since we divided by a negative 1 on both sides of the inequality. And the solutions, even though they are both relating x to negative 12, are different. X is equal to negative 12 is just one value. X is less than negative 12 contains an infinite number of values, or x is any number that's less than negative 12. Like negative 15 or negative 20, negative 100, and so on. For number 8, Joaquin and Serena are having trouble solving this inequality. Explain how they should solve the inequality, showing all the steps and identifying the properties you would use. So I'm going to rewrite the inequality to give myself a little bit of room. And when I do, I'm going to pay attention. So here I have negative 4 being multiplied to a quantity. And then on this side, I have 2 being multiplied by a quantity. So I'm going to start with the distributive property, so that way I no longer would have to worry about these sets of parentheses. So since it's negative 4 times this quantity, I'll multiply negative 4 times both the 3m and the minus 1, or negative 1. So I have negative 12m, then negative 4 times negative 1 is a positive 4. And I'll bring down this inequality sign, and then I'll do the same thing over here. So 2 times m is 2m, plus 2 times 3 is 6. So this was the distributive property. All right, next I'm going to use the subtraction property of inequality to subtract 2m on both sides of the inequality. So that way all my m's are together. And here again I'll do the subtraction property of inequality to subtract 4 on both sides of the inequality symbol. Now I'll divide by negative 14 on both sides of the inequality and get m. Now I'll need to flip the symbol to less than or equal to, since I am dividing by negative.
You get negative 1/7.
So that was the division property of inequality. Joaquin and Serena know that some equations are true for any value of the variable, and some equations are never true, no matter what value is chosen for the variable. They are wondering about inequalities. What could you tell them about the following inequalities? Do they have solutions? What are they? How would you graph their solutions on a number line? Well, for A here, we have the same thing on one side as we do the other. So these are equal, and since this is greater than or equal to, then this always will be correct. So since this is always correct, when I have my number line, I'm going to indicate that any value on this number line would work. For B, it says 3r plus 5 is greater than 3r minus 2. This is always true because if you have a value, 3r, and then here's the same 3r, and you add 5 to it, and you subtract 2 from it, the one where you added 5 will always be more than the one where you subtracted 2. So since this is always true, then your number line would look just the same as it did for A, and the solution would be all real numbers. So I'll write that down also. So the solutions for A and B would be all real numbers. Now let's take a look at C. For C here, we have 4 times this quantity, n plus 1 is less than 4n minus 3. The distributive property needs to happen here so we can better compare these values. So it's 4n plus 4 being less than 4n minus 3. Well, that can never happen. Since you have 4n and 4n, those are the same. If you add 4 to 1, and you subtract 3 from the same value, then the one where you're adding 4 should be greater than the one where you're subtracting 3. So because this is never a true statement, what you're going to have is just an empty number line, and we'll have no solution. So just to summarize, this is the same table as the previous video, but I added in the number lines. So we have our set notation, our interval notation, what the number line would look like, and then the words. So remember that if you just have less than or greater than, you have open circles. Greater than or equal to and less than or equal to have the closed circles. All right, that's it for this video. Thank you for watching.